In this video, we're going to be talking about making an interaction system completely in Blueprints. And once we're done with this interaction system, we're going to be looking at useful debugging tools we can use in Blueprints to help debug our Blueprint nodes. If you're following along from the last video of this ball project series, make sure you change your component hierarchy of our Blueprint ball character, as shown in here, since it plays a role in our interaction system. Before we get into designing our blueprints, we're first going to conceptually think about our interaction system and how a generic interaction system would work in Unreal Engine. I would first like to highlight the world outliner. As we see in the world outliner, it's important to note in the world outliner that everything it contains will be an actor, which means our interaction system can be simply put a means for two actors to communicate with each other. So in our diagram in here, we have our two actors, and our interaction system aims to bridge this communication gap. Talk to each other. Now, luckily for us, this communication is already supported by UE4 by default. And the way it's supported is through UE4's quote-unquote event listener system. To explore this idea, we will continue from where we last left off in the ball movement video. So continuing from where we last left off from the ball movement project. So before we get into designing this, keep in mind that there were additional folders that I have created, and these folders were these folders were used for our C++ interaction. Since we aren't concerned with our C++ interaction system for this video, we're simply going to ignore those folders. So pretend that the curves folder doesn't even exist. And now I have created a levels folder, and you can do this by simply right-clicking into the contents folder and write new folder, levels 2, I guess. And then you can just save that, and then the levels will appear in your levels folder. So the first thing I'm going to do before we get into designing our interaction system is I'm going to create a folder, and I'm going to say this folder is our interactions. BP_interactions. So we have our BP interactions, and the goal we're aiming for in this video is that we're going to explore the idea of two actors communicating with each other. So we can do this by creating a dummy interaction-based class. So if I create an actor and I call this actor interaction base, base, and let's prefix this with the blueprints. Okay, so we have our BP interaction base. Now if I double click on that, and I dock this there. So I'm going to be creating a static mesh in this interactions folder. Static mesh. So we have our static mesh, and I'm going to make this static mesh the root component. And I can simply do this by left clicking on it and then dragging it to the default scene root. There we go, we have it. Now it's the root component. So now we're going to explore this idea that I spoke earlier about Unreal's event listener system. So in here, if I click on the static mesh, we'll notice that the static mesh in its details panel, it will contain a list of events. And these events allows our interaction base to communicate with other actors. So if I were to say pick onComponentBeginOverlap as an event, it takes me to an event graph. And now if I drag in here, and I just want to print out the actor it's overlapping with, in essence, this onComponentBeginOverlap, this event, which is part of our static mesh, allows our BP interaction base to communicate with other actors. And in this case, we have all these other actors which are shown in the world outliner. So if I go into our interaction base, I can highlight the other actor, so I can print out who is interacting with our interaction base by dragging the node of other actor and say get name, get object name, and this will be the name of our name of the actor interacting with our BP interaction base. So if I were to just put that into the string method, we'll notice if I compile this and I save that, and in here I'm also gonna create a static mesh for this. So I'm gonna say cube static mesh cube. So if we look at our viewport, this is our cube. One thing we would also have to do is make the collisions overlap all. So if we compile that and save that, now going back into our editor and hitting play. Now going back into our editor and dragging our interaction base. So left click, drag, go, and then playing it. Now if I interact with this cube, it says BP underscore ball pawn 5 is interacting with it, which is our ball pawn. Now if I decided to use another actor, let's say our CPP pawn class, which is essentially the C++ equivalent of our ball movement, of our ball actor. So if I were to go into it and interact, we notice now it says BP CPP ball pawn. So effectively, the other actor that we see in this event system, right here, so the other actor in this pin is, unsurprisingly, the actor that is interacting with our interaction base class. This feature in of itself is pretty good in giving us a base understanding of actor communication within Unreal. But you're probably wondering how we can make it so that so that our interaction system is specifically interacting with a special kind of actor. So in our case, that special kind of actor would be our BP underscore ball pawn class, or BP underscore ball character. So how can we make it such that our interaction base is only able to interact with our ball pawn, or our blueprint equivalent ball class? And the way we were able to do this, so going into our diagram, the way we can do this is by following a concept called downcasting. If I put an arrow in here and say downcast, through the concept of downcasting, what we are able to accomplish, we can have it such that our interaction base interacts with our ball character, and it's the ball character, or specifically our BP ball character, and not our CPP ball character. So all we would have to do in Unreal to accomplish this is to go into our interactions folder, our BP interactions folder, and where I take the node for the other actor. So if I were to get rid of this and say cast to BP underscore ball pawn. Now with this cast to BP underscore ball pawn, I can take the other actor, and in the event that the cast is successful, I can drag this node and I can print out cast was successful. And then in the event that the cast failed, I can drag that out and I can say print string cast failed. And we can have this in red. So if I were to compile this and run this, or test this out, we'll notice that if I get my character, it says the cast was successful. However, a situation where this cast would fail is in the event that the cast happens to be an actor that isn't named BP underscore ball pawn. So an actor that isn't named BP underscore ball pawn. So we'll notice our BP underscore CPP ball pawn won't be able to be casted. And the reason it won't be able to be casted is because cast failed. It's because, unsurprisingly, it is not a BP underscore ball pawn. So the name of the blueprint class I chose wasn't anything unique. So let's say given a situation where you wanted a different name. Let's say if I were to make a actor called BP underscore green ball, what would I have to change in our interaction base? And I wanted my interaction system to only interact with this BP underscore green ball. Now all I would have to change in my interaction system, so if I get rid of this, all I would have to change in my interaction base, if I'm wanting it only to communicate with the green ball actor that I just created, I would delete that cast, and then I would say cast to BP underscore green ball. And there we go. That would be an example of me allowing the interaction system to only interact with, or allowing my interaction base to only interact with my green ball. So if I get this and compile this. So I have my green ball. One thing I would have to make sure though is that, so a condition you would have to make sure such that the interaction system can be called in here is that both the entities have their collision set on and both entities inherit from an actor class. So in our case, I would want to ensure that the green ball character that I just created has its collision set on. So I can do that by just, I don't know, adding static mesh. So I added a static mesh. And in that static mesh, I can add something that I know has collisions. So like a cylinder. And then from there, I can just change the collisions to overlap all. So this is just an example of getting it to work specifically for something that is very, this is just an example of having it interact specifically with actors that probably aren't named BP underscore ball pawn. If I were to, so now if I were to drag this, we notice it is calling the cast was successful, and it's occurring because the two actors have their collision set on. With that specific example, you can kind of get a, so what we should take from that specific example is that regardless of what you name your regardless of what you name your blueprint classes, all you would have to change is the corresponding cast. So I named mine BP underscore ball, green ball, but then yours would be named something different. So you can account for that using this type of cast. So I'm going to get rid of that, and then I'm going to go back into, and I'm going to go switch to select viewport, and from here I'm going to go into my interaction base and do the downcast to an actor that I do want my interaction base to interact with, which is my BP underscore ball pawn. So from here, I can put the other actor, which is the object, which is just the other actor interacting with our interaction base. And if the cast is successful, what I want to do is I want to print exactly where the interaction occurs between my ball and the interaction base. I can do so by using a node called draw debug sphere. And from here, the center will be the location of which the globe is drawn. So I have my white globe, and then I would make the duration, I would say 3 seconds. And I would say the thickness is 6. And I can get the location from which the other actor is interacting with my interaction base through this blue node in here. So through this blue node, I'm able to access everything about my ball, or my BP underscore ball actor. So I could have said anything. I could have just said, if I were to say get actor location, if I were to say get actor location, and then do a print string, and let's have that there. So before I even draw my debug sphere, I would like to emphasize that this is in fact my ball pawn actor. So if I were to click on the ball pawn, so in here I can click on my ball pawn and show the details panel. So that would be right here. And this is the location of my ball pawn. So we'll notice as I play, it will print the location in which the ball is interacting with the interaction base. And now if I click on this interaction base, we notice that it's very similar to the location of the interaction base. So in the event that the ball's coordinates is exactly this, that's when the interaction occurs between the ball and the interaction base. So going into my interaction base and getting rid of this print string, I can use the actor location, and instead of printing the coordinates, I can say draw debug sphere here, and a visual representation of this would be as follows. Let me change the duration to 2 and the thickness to 6. I'm going to compile that, and now if I were to hit play, we notice it draws the spheres a little bit too big for my taste. I'm gonna make those spheres a lot smaller. So I'm gonna make the radius around 10. That should be good. And all this is meant to do is to just show what it means for the interactions to occur, like at what specific locations do they occur at, the fact that we use event listeners that are provided through Unreal Engine. We have in this case the on component begin overlap, but then we have a collection of them that you would want to pick and choose depending on your project preferences. Maybe sometimes you would want to have a hit event as opposed to an on component begin overlap, or have an on click if you're using an iPad or something like that. So the events that Unreal provides can suit your project needs. So there's pros and cons for each one of them. So just choose one that best suits your needs. So now going back into this, we have our interaction base, which means we're able to downcast such that instead of us just communicating with every actor in the level, we are specifically communicating with our BP underscore ball class, which is the desired behavior in our case. So from here, I will choose to create 3 child classes that all derive from my interaction base. And the reason I do this is so that I don't need to create a static mesh for each one of these actors, and just have it, since it was created in its parent class, everything that was part of the parent class will by default be a part of the child class. So we have our 3 child classes, and these will all inherit from the parent, and all that means is that all the features that are part of the parent will by default be included as in its child classes. So one thing I could actually do prior to this in our parent class, so in our interaction base, is I can make it such that this event where it draws the globes, I can make it so that it's collapsed into a function. So if I were to highlight these two nodes, so left click highlight, right click collapse to function, we'll notice in the function, in my blueprint tab, there's going to be a function, and then you can name this interact. So in the event that the cast was successful, I want you to call the interact function. The reason I chose this is just because the reason I chose this was just to make it such that I have a function that I can specify its behavior in each child classes. So if I were to right click on my interaction base and say create child blueprint class and call this BP underscore pickup coin. So we have our pickup coin. The reason I chose to build the pickup coin is mainly because it's the one with the most amount of logic in it. So it's probably the best to it's probably the best to tackle in this video. So in our pickup coin, if I double click on that, we notice that everything from the interaction base is included by default in our pickup. So what we can do is we can click on our static mesh. Since it says inherited, it's inheriting it from the interaction base. And I can say, this static mesh, I want you to be cylinder. So we have our cylinder. And in addition to that, what I want to add is a sphere. And this sphere I'm using mainly to make it, and this sphere I'm creating to fill the purpose of having it so that when the actor is overlapping with our sphere, it makes the coin, it drags the coin to the character. So the sphere itself will be called collision. The sphere will be a sphere collision. So I'm going to double click on that. So we have our sphere collision. We can specify the radius through here, make it a little bit bigger than the object. Maybe too big. I would say 300 is a good size. And from here, I can add, like what we did with our interaction base, I can give this sphere an event listener. So if I click on the sphere, in the details panel, we'll notice that there is a series of events that I can choose from. Like the interaction base, I will choose to have an on component begin overlap event. And from here, I'll have the other actor. In this case, the other actor will be my ball. So I can say cast to BP underscore ball pawn. In the event that this cast was successful, that means that the actor that's overlapping with this coin is in fact a blueprint ball character. One thing I can also add for visual purposes is I can click on my coin and add another component, and this would be rotating movement. So when I click on that, so all this rotating movement does is, as the name suggests, it rotates the coin. If we go back to our event graph, now in the event that the cast was successful, in here I am going to be implementing the logic to make it such that the coin gets dragged into the ball character. Before I complete this logic, I just want to have it so that when the ball touches the coin, in the event that that occurs, I would want it to destroy the coin. So I can do this by clicking on override and overriding a function that I created in my interaction base called interact. So if I click on that, what this first call does is it makes a call to the parent, and all the parent will do is draw the globes. So the main reason of inheriting it from the parent was really illustrative purposes. So after that, I can take this execution pin and then drag it and say destroy actor. And we notice that the target is self, and all that is suggesting is that the self that is referring to the current owner actor, if you will. So in this case, self is referring to BP underscore pickup coin, but if we were to click on the interaction base, self will refer to BP underscore interaction base. So if I compile this and I save that, we'll notice, just to test this out, we have our pickup coin. So if I were to play and make the screen much larger, if I touch the coin disappears and a sphere is drawn in the point where the coin is interacting with the ball. So going back to our event listener for our sphere, we have this cast, and from here, what I'm gonna do, the way I'm able to move the pickup coin from its location to the ball's location is through the use of a lerp. So if I were to write lerp, and then it would be a lerp vector, because we're moving two vectors closer to each other. One thing to highlight is that there are currently two objects I have access to. The first object is the object I'm in, which is the pickup coin, and the second object is the ball, which is coming through this cast, or I guess you could say it's coming from the other actor, which goes into the cast to confirm that it is a ball character. So which means if I were to say get actor location, this actor location isn't referring to our pickup coin, it's referring to our ball. But then if I just right click, and say get actor location, now we'll notice the difference between the two is if we look at the target, this one says self, and then this one says target, and then that has like this blue pin that connects into here. So it's really important that this concept is understood, because it refers to a concept used in object-oriented programming, where the object that contains this function, in this case, is our ball pawn. But then for here, the object that contains this get actor location is called self, which refers to the pickup coin self. So in short, all this means is that the pickup coin the location of the pickup coin will be denoted by this node. The location of the pickup coin is shown by this node, and the location of the ball character is shown by this node. And now if I go into my get actor location, the way that the lerp works is that if I were to say value equals 20 or value equals 0.2, the alpha values are going to be any value from 0 to 1. In the event that it's 1, that means object A will be directly mapped into the location. Object A's location will be directly mapped to object B's location. So in this case, I'm trying to get the actor, I'm trying to get the pickup to move to the ball. I can do this by dragging the pickup. So now this is referring to our pickup, remember? And the get actor location for our ball will be the final destination. So move the pickup 20% closer to the ball. So now if I compile this and I run that, going back to my level, we'll notice we have our event get closer. One thing I forgot was that I did this cast, but then I never used the execution pin. So I would have to have some sort of execution pin. So I could say set actor location here. And then the location, like this will be referring to the location of our pickup. So really, like these vectors, it returns a vector, and that vector will be how much it will move the pickup, what coordinates it needs. So this return value will be the coordinate, which is 20% closer which is the coordinate which is 20% closer to our ball. So move the pickup 20% closer to our ball, so that's going to return some specific coordinates. And then through this we can say set the actor location, and we notice in here as well it refers to self, which means it's referring to our pickup self. So this is physically moving the actor's location, but then this is specifying the exact coordinate, which is 20% closer to our ball character. Yes, and through that we can compile and save that and go into our level and hit play, and we notice that the pickup is getting 20% closer to our ball. So if I maximize the screen, it's getting 20% closer to our ball. So now we notice in the demo that the coin was able to completely go into, we noticed in our demo that the ball's transition from its location to the ball's location was very smooth. So the way I was able to accomplish this is using a timeline node. So if I right click timeline node, and I can say add timeline, and then I can just say this timeline is a traction rate. So we have our attraction rate, and then from here I can take this execution, and in the event that the cast is successful, I want you to play this attraction rate, and I want you to update the actor's location. If I double click on this attraction rate, we'll notice that I can add an add float track, and this float track essentially corresponds to alpha values. So the float track in here will correspond to the alpha values we're putting into our lerp function. Alpha values. So I name that, and then I can say the length is 1 because our lerp takes in values from 0 to 1, and I can right click and I can add a key, and this key will be at time 0. I want you to correspond to value 0, and then I can right click somewhere else, and then I can add a key, and I can say at time 1 I would like you to have value 1. Now we notice if I were to hit on these two, zoom to fit horizontal, zoom to fit vertical, we have our graph. Very nice. If I were to right click on one of them and hit auto, it smooths it out in the edges so that it isn't as rough as a linear transition. So now if I were to go into the event graph, now we see these alpha values. If I were to take these alpha values and plug them into this, the logic in here is that the values I'm taking from this curve, in here we have time 0.06 corresponds to value 0.01, which means at time 0.06 on real units, I want you to move 1% closer. I want you to move the ball or the pickup 1% closer. And it's not, the curve itself isn't really moving anything. It's more how we're using the curve. We're using the return values and putting it into the slurp. And the slurp is producing a new vector, and then that's spitting it out into the set actor location. And this set actor location has a target self, which is at the end of the day, moving the pickup coin. So all this attraction rate is doing is smoothing out the alpha values such that at the very end of, such that it keeps updating the set actor location up until it gets to value 1, which will correspond to an alpha of 1 and an alpha of 1 between object A and object B, an alpha of 1 between object A, so an alpha 1 between object A, which is our ball, and object B, which is our pickup, or sorry, I had that mixed. Object A is our pickup because we're moving our pickup to the ball. So the alpha values from there will be how close it is. An alpha of 1 means our pickup is exactly in the same location as our ball. In the event that that does happen, it will trigger the interact function, which will destroy the coin. If you do have questions about this, I'm happy to answer them in the comments below as well. So now testing this out, if I have my ball, we notice my ball is now attracting the pickup as it should be. Okay, so this clears up the pickup. Our lovely pickup is completed. Now we have our jump pad and our end goal. I'm going to do the jump pad because it's slightly harder than the end goal. So let's go with that. As shown in the diagram, the jump pad inherits from the interaction base, just like the pickup did. So I can mimic this behavior, or I can exactly show this behavior by right-clicking on the interaction base and say create child blueprint. So now in here, I can right-click to rename it and call it jump pad. From this point, I can double-click on the jump pad, and as noticed, since it's inheriting from the interaction base, it will have the static mesh of the interaction base. That's not a big issue. We can override the static mesh. We can override the static mesh and say this is in fact disk. That would be a better jump pad. So we have our cute little disk. So in here, we notice the static mesh, which is inheriting from the parent. So this static mesh already has an event listener through its parent class. So all I would have to do is hit interact and draw the globes. That's fine. I want that behavior. But in addition to that, affect the ball's height. And I can do this by using either an add force. So I can right click, add force, and then the target will be a static mesh. So now it's important to acknowledge what's happening in here. Unreal has by default said the add force I'm gonna apply, or even better, since I used an add force in the last video, I will say add impulse. They have the same behaviors, or they're implemented differently, but they sort of have the same behaviors in that one, they're adding force to one object. In this case, we notice that the static mesh is like the target is connected to a static mesh, and really all this means is the static mesh is for the jump pad. This will be an issue because we want our jump pad to affect our ball and not the other way around. To make it such that our ball is being affected, so we notice it gave an error, and it's because it needs some target to be connected to it. So the way we're able to fix this error is, or the way we're able to get a reference for our interaction base is we go to the parent event listener, which is part of the interaction base. I can right click on this and say promote to variable. In doing so, I'm storing a reference of the actor that interacts, which is the BP_ball pawn, and I'm putting it into the interact function here. So I can name this variable in here, and I can call this variable overlapped ball character. There we go. Compile this. Okay, so it compiles for this. And now if I were to right click in here, get overlapped ball character. Now everything in this node, coming out of this node, will not be referring to our jump pad anymore. It will be referring to our overlapped ball character, which is this guy right here. The target is self. I don't want you to affect the self. I want you to get the overlapped ball character, and I want you to target the static mesh of the overlapped ball character and not the jump pad. So in the overlapped ball character, I can drag a node and say get static mesh. static mesh. So at the very end, we have our get static mesh, and then I can connect this to our add impulse function. In doing so, I have it set up such that the thing that will be affected when the interaction occurs will be the the ball instead of the pickup, or the thing that's going to be affected will be the ball instead of the jump pad. And the impulse I'm going to add can be an arbitrary number. I will just say 1200 since it might be too big, but you can modify these values to whatever you see fit. Now I can take the jump pad in here and play the level. Okay, so if I test this out, we have our cute little jump pad that sends me flying. I bounce it here, get it over there. Nice. Okay, so now we were able to get the jump pad. Now let's take it home with the end goal. Our nice little jump pad is gone. Now we just have the end goal. So if I were to click on this and then say create blueprint class and do BP underscore end goal. So from here, all I would have to do is kind of cheated my way through this one. I have the static mesh. I will override it and call it help. Editor help. And then from here, I said, okay, let's make this rotating. So I add a component, rotating movement. So we have our rotating movement, and I can compile this. Okay, so I compiled this, and what I can do, once I click on the static mesh, I can go into the override section, and I can override and the interact function. Now I have these connections, and I can say print string, and then I can say end goal. And from here, I can do maybe different colors. So I can make this green, and then I can change the duration to 10. Might be. So now, if I take my end goal and have it so that my character can interact with it, so the coin and then the end goal. So we have our nice little message at the very top left. So in this part of the video, we're going to be looking at ways we can debug our interaction system. So if I were to double click on, let's say, the pickup, and I want to debug my interaction system, the way I'm able to do so is click on, let's say, the cast, is you can hit F9, and what you can do from there is you can go back to your level and play the game normally, and from here we'll notice it will call this debug session in the event that this function is being used or this blueprint is being used. So you have a series of options you can use. There's one that's resume, and then if you click on this right arrow, there's one that's step into, like you would see in normal debugging tools. Step into, step over, step out, and there's a frame skip as well, and a stop. So if I were to do step into, it will tell me exactly what node will be called. So in the event that the cast is successful, this node is being called. So then from here, I can go in and do step into one more time, and step into, and then it calls the set actor location. From there, I do step into, and we notice that it will end and it will call the execution. Okay, so this concludes the video. I hope you enjoyed it. I enjoyed making this, and yeah, let me know if you have any feedback for this.